Hello, class. I'm creating a video to help with a couple of the exam problems. So first, it looks like you toss a coin 100 times, you get 85 heads and 15 tails. Based on these results, what is the probability that the next flip is a head? Well, ordinarily, I would say if we knew the coin was fair, it's always going to be 50-50, right? The probability of getting a head or a tail is always going to be 50% the next coin toss, excuse me. Got marbles in my mouth. But in this case, if we did it 100 times and you get 85 heads and only 15 tails, maybe this coin is not a fair coin, right? So we can't assume it's going to be 50-50. So in this case, I'm going to assume the probability is going to be 85% or 0.85. Check answer, and we get the correct. Next question. Okay, so it says 42.7% of 3-year-olds are enrolled in daycare. What is the probability that a randomly selected 3-year-old is in daycare? Well, that would be your 42%, right? But just written as a decimal, 0.427. Check answer, we get the 100%. Next question. Okay, now they want us to complete the table below. So it looks like 5 offenses for pickpocketing, 6 for purse snatching, and this is out of a total of 617. So I need to divide each of these numbers by 617. I wonder if I can do that in StatCrunch easily. Let's take a look here. There might be a quick way to do this, right? So here's our data. So if I know I have to divide everything by 617, right, maybe I can kind of create some type of formula, using the expression formula. So if I click on data, compute, here we go, expression, I'm going to build an expression. So if I take the number of offenses and divide by 617, so I actually didn't have to add that column in there, and then I create a new column, so I press OK, and compute. You see what happens there? It gave me a new column with all the values here. So I have to round 3 decimal places. So I have to put in like 0.008 for pocket picking, and then 0.009, which rounds to 0.010 for purse snatching. So I'm going to transfer all of these values into here, but round it to 3 decimal places. So I'll pause for a second. And here are all my values. Again, it was tedious to transfer these values here and then round to 3 decimal places, but that's what they were looking for, right? So again, I divided the number of offenses by the total offenses and got my percentage. Then it says, are purse snatching larcenies unusual? I said yes, because purse snatching was less than 5%. This looks like 1%. So anything less than 5% would be unusual. Motor vehicle larcenies unusual. Well, that's greater than 5%. This is 13.5%. So I would say no, this is not unusual because the probability is greater than 5%. Right? So anything less than 5% is unusual. Greater than 5% is not unusual. And I think that's it. And we get the 100% correct. Let's see. Maybe we'll do one more. Okay, so it says the probability experiment is conducted in which the sample space, and they give us the sample space, event E, event G, and it says list the outcomes in E and G. All right, so the outcomes for E and G would be 2, 3, 4, 5, 7, 8, 9, 10, right? 2, 3, 4, 5, 7, 8, 9. I just realized I made a mistake. I did E or G. Right? E and G would be the empty set. right? And then are E and G mutually exclusive? I'm going to say yes, because E and G have no outcomes in common. Let's check the answer. 100% correct. So again, I just want to make sure. I almost made a mistake because I read this as E or G, but E and G, that's what's in E and G. There's nothing in common here, right? This is 2, 3, 4, 5. That doesn't appear in G, and 7, 8, 9, 10 does not appear in E. So that's why I put the empty set. And I said, yes, they're mutually exclusive because E and G have no common outcomes. Let's do one more. Number 5. Find the probability of P or F. I'm sorry, probability of E or F if E and F are mutually exclusive. So I wanted to show you our probability sheet, right? The probability of E or F is equal to the probability of E plus the probability of F minus the probability of E and F. Now remember, we said that these are mutually exclusive, meaning P of E and F would be 0, right? When you have mutually exclusive, this value would be 0. So really, we just have to add E plus F. So in this case, 0.25 plus 0.51 is 0.76. Check answer, 100% correct.